Hello everyone. Today we are going to write linear systems to solve real-world situations and solve systems by adding and subtracting. So we're going to look at this first example and we see that it is not lined up. The x's are lined up, but the y's, it looks like the y's are lined up, but they're really not because the equal signs are not lined up. So we have to move this equation around to get the x's and the y's on the same side of the equal sign. So in order to do that, we need to subtract 3y on both sides. So that gives us x minus 3y equals 11. So we're going to take that new equation and put it with the original equation, and then we'll be able to solve for step number 2. So we've got 1x minus 3y equals 11. And then we've got the original equation, 2x minus 3y equals 16. Now, we see that we have two of the same number here, and if you have the same number with the same sign, we're going to do same sign subtract. Same sign subtract. So we're going to subtract the two equations together. 1 minus 2 is negative 1, x. Negative 3 minus negative 3 is 0, so we can mark that out. 11 minus 16 is equal to negative 5. Now we're going to solve this equation. So we're going to divide both sides by negative 1. So my negative 1's cancel, and x is equal to 5. That's my first important piece of information that we have. Once you get x equals 5, then you're going to plug it into one of the original equations, and we're going to use the 2x minus 3y equals 16. Actually, no, I'm not. I'm going to use the equation that's already solved. No, I am. I'm going to use this 2x minus 3y equals 16, and I'm going to solve for y. So I've got 2 times x, which x was 5, minus 3y equals 16. It doesn't matter which equation that you use as long as you use one of the originals, so that way you don't mess anything up. 2 times 5 is 10. 10 minus 3y equals 16. We got to move the 10 to be with the 16, so I'm going to subtract 10 on both sides. My 10's cancel. I'm left with negative 3y equals 6. Divide by negative 3. My negative 3's cancel. I'm left with y equals negative 2. That's my second important piece of information. Now I can write it as an ordered pair on step number 5. My ordered pair would be 5, negative 2. Now let's try on example number 2. We first have to see if they're lined up. My x's aren't even lined up this time, my y's aren't lined up, and my equal signs aren't lined up, so we need to move this top equation around to make sure that the x's and y's are on the same side of the equal sign. So in order to do that, I've got 4y equals 2x minus 8. I'm going to subtract 2x on both sides. Now I cannot combine these two things because they're not like terms. So I'm just going to rewrite it. Negative 2x plus 4y equals negative 8. Now I'm ready to write this second equation and directly underneath it. 5x minus 4y equals 20. Now, we need to decide, are we going to add or subtract? Looking at my 4's, are they the same sign or different? They're different signs, so I'm going to add the two equations together. Negative 2 plus 5 is 3x. Positive 4y plus negative 4y is 0, so I can mark those out, equals negative 8 plus 20 is 12. Now we're going to divide both sides by 3. That cancels. I'm left with x equals 4. Now that I have x equals 4, that's one important piece of information. I can plug it into one of the original equations. So I'm going to plug it into the bottom equation because I haven't touched that one yet. I haven't rearranged it or used it. So here we go. 5x minus 4y equals 20, and x is 4. So now we're going to simplify this equation. 5 times 4 is 20, minus 4y equals 20. I'm going to subtract 20 on both sides. This 20 cancels. I'm left with negative 4y equals 20 minus 20 is 0. Divide both sides by negative 4. My 4's cancel, so y is equal to 0. That's my second important piece of information here. So I can write my ordered pair as 4, 0. Example number 3. Example number 3 is not lined up. The x's are lined up, and it looks like the y's are lined up, but notice that the equal signs are not lined up. So we need to make sure that we rearrange this top equation. And it could be the bottom equation that you need to rearrange, but how it's typed out, it's been the top equation every time. It's been the top equation every time. So we're just going to rewrite that top equation down here so we can simplify it. 3x equals 4y minus 10, or not simplify it, so we can rearrange it is what we're trying to do. So we need to move this 4y to be with the x, so we're going to subtract 4y. That gives us 3x minus 4y equals negative 10. Now I'm going to rewrite this other one directly underneath it. 3x minus 4y equals negative 13. Now, if we want to cancel the x's, or if we want to cancel the y's, it doesn't matter this time. They're the same sign, so remember, same sign, subtract. So we're going to subtract these two equations together. 3 minus 3 is 0. Negative 4 minus negative 4 is 0. So we have 0 on this side equals negative 10 minus negative 13 is negative 3. No, it's not. It's positive 3. Sorry. It's positive 3. So, does 0 equal 3? It does not equal 3, so this one would be a no solution. That's what a no solution problem looks like. When all of the variables cancel out and this makes a false statement, your answer is no solution. All right, let's look at example number 4. Again, they're not lined up, so we got to line it up. We're going to subtract the y on both sides. So we've got 5x equals y plus 6. Subtract the y. So that gives me 5x minus y equals 6. And then I'm going to write the other one directly below it. 5x plus 2y equals 3. Now my 5's are the same sign, so same sign, you subtract the two equations together. 5 minus 5 is 0. This is a negative 1 minus 2, which is negative 3. Equals 6 minus 3 is 3. Divide both sides by negative 3. So y is equal to negative 1. That is my first important piece of information. Now we're going to take that negative 1 and we're going to plug it into the bottom equation because we haven't used that one yet. 5x, my pen doesn't work. Let's try again. 5x plus 2 times y equals 3, and y is negative 1. So we have 5x minus 2 equals 3. And where I got the negative 2 from was positive 2 times negative 1 is negative 2. And then we're going to add the 2 to both sides. This cancels. We're left with 5x equals 5. Divide by 5 on both sides. My 5's cancel, make 1. X is equal to 1. So this ordered pair would be 1, negative 1. Example number 5. Example number 5, my x and y is on the same side on the top equation, but on the bottom equation it's not. So we need to move that bottom equation around by subtracting 2x. The 2x's cancel, so I'm going to rewrite this as negative 2x minus y equals 10. And that top equation there was 2x plus y equals negative 10. And now I'm going to look at the two equations to figure out if I need to add or subtract. Looking at my x's, they're opposite signs. So if I want to get rid of my x's, they're opposite signs. So I'm going to add. Opposite signs, you add. Negative 2 plus 2 is 0. Negative 1y plus 1y is 0. So we're left with 0 on the left side equals 10 plus negative 10 is 0. Does 0 equal 0? Yes, it does. This is a true statement. When you get a true statement and all your variables cancel, this would be infinitely many solutions. Example 6. The top equation has x and y on the same side, but the bottom equation does not. So we're going to rearrange that bottom equation real quick. So 7x needs to be subtracted on both sides. So my 7x's cancel, so I'm left with negative 7x. That's a positive y equals 67. And then I'm going to rewrite this bottom equation directly, or this top equation directly below it. 2x minus y equals negative 22. Now, if I try to add the two equations together, negative 7 plus 2 is negative 5. 1 plus negative 1 is 0, so that will work. So we can add the two equations together. We said that this was negative 5x. This cancels, and this is equal to 45. We're going to divide by negative 5 on both sides. That cancels. We're left with x is equal to negative 9. That's our first important piece of information, so we're putting it in a box. And then we're going to plug it into that top equation because we haven't rearranged it yet. So when we plug it into that top equation, we've got 2x, and we know x is negative 9. Minus 1y equals negative 22. Okay, so 2 times negative 9 is negative 18. Minus 1y equals negative 22. We're going to add 18 to both sides. So that gives me negative 1y equals, because this cancels, negative 4. Divide both sides by negative 1. So y is equal to positive 4. This is my next important piece of information. So my ordered pair would be negative 9, positive 4. All right, our last example. We're looking at 6x minus 3y. Those are on the same side of the equal sign, so that one's good, is equal to negative 21. And then we have 4x equals 3y minus 9. And that is not on the same side of the equal sign, so we need to move this 3y over to the other side. In order to do that, we need to subtract 3y. So that gives me 4x minus 3y equals negative 9. And then I'm going to rewrite this one directly below it. 6x minus 3y equals negative 21. Now, they're the same sign, so we're going to subtract the two equations together. So 4 minus 6 is negative 2x. Negative 3 minus negative 3 is 0. Equals negative 9 minus negative 21 is a positive 12. Divide both sides by negative 2. So x equals negative 6. That's my first important piece of information. Now we're going to plug that back into the top equation. So that's going to look like this. 6 times x minus 3y equals negative 21. And x is negative 6. 6 times negative 6 is negative 36 minus 3y equals negative 21. We're going to add the 36 to both sides. This will cancel. I'm left with negative 3y equals 15. Divide both sides by negative 3. So y is equal to negative 5. It's our next important piece of information. So we write this as an ordered pair, negative 6, negative 5. That finishes up our lesson today for solving by elimination and by adding or subtracting. So today you have a pair assessment for you to complete, and I hope you all have a fantastic day.